Hi, this is a supplementary math lesson for Algebra 1, Lesson 83, Operations with Scientific Notation. So we did a review of expressing numbers in scientific notation and how to modify numbers in scientific notation. And at the end of that exercise, we kind of started using our tools, our rules of exponents to combine multiplied numbers together that were in exponential form or in scientific notation. Now, that was leading up to this next lesson, okay, operations with scientific notations. Now we're going to limit our discussion, our operations to multiplication and division right now. And so if you remember, according to our last lesson, when we have numbers expressed in exponential notation here, it's not proper scientific notation because we don't have an integer followed by a decimal. We have the decimal in the wrong place. Okay, here we have a proper scientific notation. Okay, here we just have two numbers, a small number, rather large number. Okay, and over here we have a combination of large numbers and exponential notation numbers, and well, we don't have a proper scientific notation number. Okay, so in these problems, when you see times power to the 10, it's an automatic clue in that you need to express the answer in scientific notation. Okay, in this case where it's not, we'll see what the answer becomes. It might be more helpful to express that answer in scientific notation. So these are all example problems in your book on page 297 and 298. If you want to pause the video and turn your textbooks there, you're welcome to do that now. Okay, so these homework problems you can use your calculator on. Okay, the book has you doing it a different way. They have you turning every number into the problem into scientific notation and then doing your multiplication and division. Okay, I'm not so much interested in that because there'll be enough practice with putting numbers in scientific notations, even with using your calculator. To me, the way they require it there to do that, and we'll see, it doesn't really, it adds a lot of steps to it, and what it does is it introduces a lot of possibility for error. Okay, now if you want to do that the way the book is doing it, you're welcome to do that. You can read through and show, but what I'm recommending is we're going to handle the numbers by themselves and then the powers of 10 by themselves. Okay, we'll multiply and divide the numbers with our calculator or using our brain, and then at the end turn the answer into proper scientific notation. So remember from our last lesson, I said what we have here in the case of this exponential number, we have a number and a power to 10 times another number times another power to 10. We effectively have four numbers multiplied together. In our rules of multiplication say it doesn't matter which order that we multiply them together. So what I'm going to do, I'm going to handle the numbers separately. I'm going to use my calculator, 0.003 times 2 equals, and it gives me a 0.006 for the numbers. Okay, then I'm going to multiply my powers of 10. This is example 83.1 in your book. Okay, so this is the part I do with the calculator, the numbers. This is the part I do in my head. I have a power of 10 to the minus 4, and I have a power of 10 to the 20. When I multiply powers together of the same base, I add the exponents. So I have a minus 4, a plus 20. It turns out to be a plus 16. Okay? You want to do that in your head and combine it into 16 there, you can. If you want to go ahead and put that minus 4 plus 20 and then make it to 16 in the next step, you're welcome to do that. Okay? So now we have the number times the power of 10. Now let's change it into scientific notation. Okay? We want that decimal place moved over 3 spots, so it's now a 6.00 times 10 to what power? Okay, well, what have we done? Okay, we have made this number 3 decimal places bigger. We have to make this number 3 decimal places smaller. 16 minus 3 is 13. Okay, let's check the book answer. 10, 6 times 10 to the 13th. Okay, that's what they have. Okay, what they did is they changed this to scientific notation and this to scientific notation, and then they multiplied the number and the power of 10. Okay, we did the same thing. We just didn't do that first initial step. It adds 2 steps, adds a step up here, and adds a step down here, and as we'll see in this next problem, actually adds a 3rd step unnecessarily. The more steps you do, the more chance for error. Okay, and that's why I say go ahead and use your calculators for this. Now, in this case, 83.3, and that will be the next page over on page 298. Okay, they don't give either of these numbers in an exponential or a scientific notation form. They're just numbers. Well, let's just punch the numbers in the calculator and see. 0.0016 divided by 400,000. Okay, and of course, on my calculator, what I get is a 0 point, then I get 8 zeros, 2, 3, 4, 5, 6, 7, 8, 8, and then a 4. And that's the limit of digits that can actually show on the screen in my calculator. So in my mind, I'm not quite sure if there's more that's going off the screen, but in any event, okay, this is a really, really, really small number. We would hate to keep writing this number over and over again in an equation or an answer, or just carrying it along in a problem in a scientific or engineering sense. Okay? A lot of zeros, a lot of possibility for error of leaving a 0 out or putting another 0 in. So this is a good candidate, okay, for exponential notation in the final answer. Well, let's just do that right now. We can change it to a 4.00 times 10 to the what? I want to move the decimal place over 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Okay, I've made the number bigger by 9 decimals. I have to make this power of 10 smaller by 9 decimals to make it equal. Right now it has no power of 10, so to make it smaller by 9 decimals, I add a minus 9. Okay, that is the answer. Let's check the book. That is the answer they had. Okay, so their method is, one way you could do that is change this into 1.6 times 10 to the 1, 2. I'm moving that decimal place over 3 places. Okay, I am making this number bigger by 3 decimals. I make this number smaller by 3 decimals, minus to the 3rd. I make the bottom number 4.00 times 10 to the, I'm moving the decimal over 1, 2, 3, 4, 5 spots. I've made the number smaller by 5 decimals, so I have to make this power of 10 bigger by 5 decimals. Okay, fifths. Okay, now let's go ahead and divide 1.6 divided by 4 equals 0.4. Okay, 0.4 times 10 to the what? Well, I notice when I have a division of exponential powers, I have to subtract them. It would be minus 3 in the numerator, minus, subtracting, a minus 5 in the denominator. Okay, that equates to a minus 3 minus, I'm sorry, not a minus 5, a plus 5, minus 3 minus 5 will equal a minus 8. Okay, not the same here because this one is not in scientific notation yet. The decimal is off by 1 decimal. I have to move the decimal over 1 to the right. Okay, I'm making that number bigger by 1 decimal. So I would change this power of 10 and make it smaller by 1 decimal. It would equal 4 times 10 to the minus 9th. The same answer we have up here. Okay, so what happened there? If I change the numerator into a scientific notation number, I change the denominator into 1. Okay, I've added 2 steps right now. Okay, my result ends up in a number that's close to scientific notation, but not quite. So I have to change that number into scientific notation. Anyway, that's a 4-step process. I change the numerator into scientific notation, change the denominator, okay, I do the math, then I have to change the answer into proper notation. Here, all I did was change the, I go ahead and did the math in the calculator, and then I changed the calculator number into scientific notation. 2 steps versus 4 steps for the book. That's why I say, you know, if you want to real practice scientific notation, go ahead and do it by the book. But we'll have enough of that in these problems because more likely than not, you have to change the final answer into scientific notation anyway. Okay, let's go to our last example, 83.5, and that is also on page 298. And we have a combination of multiplication and division here. Okay, so let's just go ahead and do it my way and see how it comes out. Let's put in 20 times 400, okay, divided by 100,000. Now, the next number is also in the denominator, so on my calculator, I have to put divided by again because it's still in the denominator. So any number in the denominator, I proceed with the division sign, okay, no matter how many they are. And so it's going to be 0.0008. I'm checking to make sure I got it in there right. And I hit the equals. And what do I get? I get the number 100. Well, gee, that's not such a big number or small number. Certainly not like this one over here. That's pretty easy to handle. Good deal, okay, for me. So I'm going to multiply it by the power of 10. Okay, now this is where you want to go ahead and add and subtract your exponential powers. Okay, I have a minus 45 right now in the numerator. I multiply it by another one in the numerator, which means I add the exponents. It's a positive 20. Okay, now I am dividing by a power in the denominator. When I divide exponential powers, I subtract them. Okay, what am I subtracting? I'm subtracting a minus 15. Okay, so effectively this becomes an addition. Okay, and I can go ahead and just add those numbers on my calculator. I'm going to type in a negative 45 plus a 20 plus a 15. It equals a minus 10. I'm just going to put an equal sign there, a minus 10. So what does this number equal? It equals 100 times 10 to the minus 10. Okay? So again, we still have practice putting the final answer into scientific notation. It's going to be 1.00. I have moved that decimal place over 2 times. Okay? I have made this number smaller by 2 decimal places. I must make this number, the power of 10, bigger by 2 decimal places to equal the number out, okay? 2 decimal places bigger than minus 10 is minus 8, because minus 8 is a bigger number further on the right in our number line than minus 10 is, okay? And let's check our answer with the book. 1 times 10 to the minus 8, okay? So that's the same answer that they had in the book. So if you want to use the book method, change everything in the exponential notation, then do your multiplication and division, okay? Or just go ahead and use your calculator. Do all the numbers on your calculator, math-wise, using it that. Then use your brain to combine the powers of 10, okay? If you could do it in your brain and combine them, or you can always list them out, okay, and then combine them in the next step like we did here, especially when there's multiple powers involved. Might not be a bad idea. So I hope that helps, okay? Just remember, keep the numbers separate, do them with your calculator, keep the powers of 10 separate, do them in your head, combine them into a number, and then change them at the last step into a scientific notation. I think that's a little less steps than the book teaches. So hope this helps. Shoot an email or a text message with any questions. So long for now.